Alright everyone, welcome back. Today we're gonna solve problem partition to k equals some subset. So basically this problem, you will have an input array num and you will have a k. In this case is 4, right? So our job is to make sure that this number array can be split into 4 parts, and they are all of them are equal. For this case, you can see right here we have a 5 and 1 4, which is 5 2 3, also 5 and 2 3. So that is it, and we have to figure that out. So if it's true, we return true. If we cannot do anything, we return false. Okay, so first of all, we know that is we have to split it in 4. So meaning that the sum of all this element in the array, sum of this element in the array divided by 4, it must be dividable by 4, right? So if the sum of this mod 4 is not equal to 0, so we can just immediately return false. Yep, something like that. All right. So now let's solve it. Okay, our target, right? Because we want to split this number into equal portion, and then we want 4 of them. So our target would be the sum, right? Sum of every one divided by 4. So in this case, what we're going to do is we are using a technique called backtracking, and specifically I'm going to use the choose or not choose kind of technique. So in this case, at 4 we will have a decision tree, which is 4, or we're not choosing 4, and it's going to be 0, right? We will definitely maintain the sum of that, but just focus on this first. Okay, now we have 4. We're going to choose 3. Oh, sorry, 3 right here. So it's sum up to 7, or we're not choosing anything. It's still 4, right? So in this part, since we're not choosing 4, we will have an option to choose 3 or not choosing 3. Same thing in here. We have a choice to choose 2 or not choosing 2, which is 5. We have 2 scenario right here. We have 7 and we have 5. In the case that the total sum of 3 and 4 is greater than our target, what we do, we just don't care. We're not going further. We're not like choosing anything else. We just cut right here, right? We just cut it like that, and then let's see. All right, so when we have 5, what we're gonna do, we say, okay, we found it, which one create this find? Okay, we have 3 right here and this 2, right? So since we have these since these 2 create the 5, we say we will mark these 3 and 2 as we are used already, and then whenever we have 5, we will want to reset everything. So what I mean by resetting it means that we will have like a smaller portion of the problem where we just need to find when the k is 3, right? Yeah, when the k is 3. So this is when we resetting it. We reset our current sum. We will make the decision tree one more time. And yeah, that is just basically it. We will keep doing that until our k right here is equal to 0. Right, the same process, we do it again. We check that, okay, 4 in we have like to choose 4, not choosing 4, and then when we meet the 3 and the 2 right here, which we mark it as we use, we just skip it, like just exactly like the 7, we skip it. Let's jump right into the coding part. Okay, let's do our coding part. As I said before, we will check the sum of the numbers, right? If it is modded by k, we would, if it's mod by k, if it's divisible by k, we will return false, right? And then so now I'm gonna try to initialize our target. So our target would be equal to the sum. Same thing, sum divided by k. Right? Okay. So as I shared with you before, we will have to mark if we're gonna use that index, like that element in the array. How I'm gonna do it, I'm gonna have an array that is determined if I'm using that element or not. So false multiply with the length, just like that. So now what I'm gonna do, this is not here. So now what I'm gonna do is I'm gonna declare our DFS function, because we have a decision tree. It's backtracking. So in the I of k, and I will pass the I, the k, and the partition sum, like that. In here, our base case is if k equal to 0. So when we are able to finish everything, right? Because we keep decrement our k, and we restart it. So in here, if k equals 0, we return true. Now, when do we restart our DFS? We restart it when the partition sum is equal to our target, right? So that is when we gonna reset. So reset everything, but we have the k minus 1, something like that, right? So now we'll have another variable right here, because we're gonna choose, right? So for j in range of I length sums, right? So for every single element, we're gonna choose it or not choosing it, right? So if that element is used, it is used. So if the use j, right? If that element used is true, meaning that I already use it, I'm not gonna do anything, right? As let me open. Yep. As I'm using this already, I'm just gonna continue. I'm not gonna jump into it and do any kind of DFS in here. Exactly the same like the case when it's bigger than the target that I'm looking for. So if use J or the partition sum, right, plus the num of J is greater than our target, I'm going to continue. All right. So now when so for backtracking, I have not for our backtracking, if we if that element is not used, right, we have to mark it as it is used. So we mark it as is used. All right, and then we run our DFS. So DFS, we run our DFS function. We pass the next element, and we pass out k. We pass our current sum, right? So in this case, what if is return? What if in here in this DFS function is returning true? We want to return true in our DFS, right? So if DFS, right, this is just basically say it's true, we will return true in our function. And then after that, after we do our DFS, everything is good. It's not returned true yet. What we do is we backtrack. So we use J equals false, and then in the end of this function, let's see, where is it? End of this function, we're just gonna simply return false because yeah, not hidden true case yet, so we return false. After that, we will return the DFS. We just simply call that function, right? Function. All right. So this is how the code is. That is it. But there is also some optimization into this solution. All right. So this one is a little bit optimized since we sort. We're gonna sort our nums, our elements in the reverse order. And we also add the line that highlighted right here. So in case that when we are finished our first DFS, like our first backtrack call, and the partition sum is still 0, nothing is changed, we returns for immediately. So we cut the part that is go deeper in the DFS. So yep, this is just a slightly more optimization, and that's it. That is all about this problem. For the runtime complexity, it's gonna be O of k multiply with 2 square n, because 2 square n is the decision tree. It's just 2. Decision tree is just 2. K in here because we whenever we find a partition, we call our k again. So that's why there is a k number right here. For our space complexity, since we use our use function, we're gonna have an O of n. Right. So that will be it. Thank you for watching.